3.4 notes are on the distance between 2 points. We'll start with this warm-up. Look at number 1. What is the distance between the 2 points on the number line? Did you say 4? Did you count? 1, 2, 3, 4? That works fine when you get the graph. The fact that we have the number line there makes that easy, just to count to 4. What I also want to point out to you is you could find that distance by taking the larger number, -1, and subtracting the smaller number, -5. Minus a negative is plus a positive, so that's another way to get 4 as well. Use the same idea on number 2. The bigger number is 7. Subtract the smaller number from the bigger number. 7 minus -3 is the same as 7 plus +3. I'm sure you already found out that that's 10. Let's look at distance again, this time in the xy plane. Now we have 2 points, A and B, and we want the distance between those 2 points. I'm sure you can count how many units it is between the 2 points. Let's see if that matches with this approach. Take the coordinates of point A, they are 5, 4. Then the coordinates of point B, they are 5, 1. And look at what we have. The x coordinates are the same, they are both 5s. The y coordinates are different. Let's subtract the y coordinates. When you do the subtraction, make sure to take the larger number minus the smaller number when you do that. Did you get 3? Now look at a horizontal segment. The coordinates of point C are -5, 2. The coordinates of point D are 3, 2. Look at the ordered pairs. Do you notice that the y-coordinates are the same? Since the y-coordinates are the same, let's subtract the x-coordinates. Remember to take the larger x-coordinate minus the smaller. Answer is 8. How can you tell when you can determine the distance between 2 points by subtracting the x-coordinates of the 2 points? We were able to do that when the y-coordinates were equal. How can you tell when you can determine the distance between 2 points by subtracting the y-coordinates of the 2 points? We can do this when the x-coordinates are equal. Here are 4 problems for you to practice. Please pause the video, try the 4 problems, then turn the video back on to check your answers. Number 11, since the x-coordinates are equal, I'm going to subtract the y-coordinates. Always take the larger one minus the smaller. Number 12, the y-coordinates are equal, so subtract the x-coordinates. The 5 is bigger, so I'll put 5 first. 5 minus -8 is 5 plus +8. Number 13, the y-coordinates are equal, so subtract the x-coordinates. Number 14, the x-coordinates are equal, so subtract the y-coordinates. We looked at situations where the points were forming a horizontal or vertical segment, and we could find the distance between them just by subtracting x-coordinates or subtracting y-coordinates. But now the points will not be lined up vertically or horizontally, so we're going to have to figure out a way to find the distance between the 2 points when they are not vertical or horizontal. The graph below represents the sidewalks in a nearby neighborhood. Each unit on the graph represents 1 step. Suppose you want to walk from A to B. Using the sidewalks in order to stay off the grass, you start at A and walk to C. From C you walk to point B. What type of angle do we have at the corner of angle ACB? We have a 90-degree angle at that corner. How many steps are in the walk from A to C? How many steps are in the walk from C to B? How many total steps are in the walk from A going through C all the way to B? You decide to take a shortcut and walk through the grass. So this is the way your path would look, drawing a segment straight from A to B. Remember where point C was a moment ago? If you draw in AC and BC, what kind of triangle do you have now? It is a right triangle. What would side AB be called in the right triangle? Since we have a right triangle, it would be appropriate for us to use Pythagorean theorem. Now, what you've done in the past is you've set up C on the hypotenuse. We have a 3 on a leg and a 4 on a leg. And you would set up C squared equals 3 squared plus 4 squared. Starting from now on, I want you to consider not writing the setup like that. Instead, write the setup with the square root in it. So pretend you've already square rooted both sides. It would look like this. C equals the square root of 3 squared plus 4 squared. We found the distance between A and B to be 5. I'm sure you could have done that without the Pythagorean theorem. But now that we have, which path is the shorter distance? Walking the sidewalks through point C or just going directly through the grass? So what we have here is the distance between 2 points is actually going to be found using the Pythagorean theorem. We will find a horizontal distance and we will find a vertical distance. And we'll use those two to calculate the distance between 2 points. Now, it's customary to call that distance d. It is also customary to talk about that horizontal distance as a change in x. And more recently in Algebra 1, that is referred to as x sub 2 minus x sub 1. The vertical distance is thought of as the change in y. And we would write that as y sub 2 minus y sub 1. You saw that notation in the formula for slope. So now, if I take these sides and square them, my distance formula will look like this. I'm not going to set up d squared. Remember, I'm going to write a square root. The change in x can be written x sub 2 minus x sub 1, then square it. The change in y is y sub 2 minus y sub 1, and then square it. So this is the distance formula between 2 points. Let's practice using the distance formula in number 12 through 14. Given the points 2, 4 and 14, 12, we're going to need a horizontal change. From 2 to 14, what is the change in x? The change in x is 12. Now do the change in y, or delta y. Hopefully you're doing 20 minus 4. That's 16. So I drew a little triangle there, which you do not have to draw, but that's our picture for horizontal change and vertical change. And so using that setup, we can write the distance formula. And please write it with the square root right away. So the change in x, or the horizontal change, was 12, so square that. And then vertically it was 16, so square that. And the square root of 400 is 20. Please pause the video. Try numbers 15 and 16, then turn the video back on to check your answers. We are not always going to get answers that turn out as whole numbers. The next few examples will be ones that do not have answers that are whole numbers. So we'll start with number 17. Find the distance between -4 to -2 and 2, 0. The change in x is going to be 6. The change in y is 2. So this is an exact answer. Sometimes I'll ask you for an exact answer, but then in part B, sometimes I'll ask you to round it. So take that number and round it to the nearest tenth. On your calculator, you can type in 2 times the square root of 10, or you can just type in the square root of 40. Okay, it's your turn. I want you to try number 18, but before you do, could you change the 10 at the end to an 11? So do number 18 on your own. Pause the video, find the distance between -10, -5 and -2, 11. Then turn the video back on to check your answers. Number 19. To find the longest leg of a triangle, I'm going to set up distance between these 3 points. First, I'll find the distance between the first and second. I'll call them A and B. Then the distance between B and C. Then I'll find the distance between A and C. And you'll know what I'm doing because I'll write a subscript with it. So here's the distance between A and B. The change in X is 2. The change in Y is 6. When you get the square root of 40, stop. Don't simplify it yet. Let's check the other 2 distances the same way. That should give you the square root of 50. If you simply compare the square roots now, can you tell which one's the biggest? So root 50 is the biggest. We can simplify it now. We will get 5 root 2. The question asked for the length of the longest side, so you are done. Activity 3. We're going to warm up on adding and subtracting radicals. To add or subtract radicals, you need to simplify all the radicals, then combine like radicals. Number 1, 4 root 5 and 2 root 5 are like radicals. 4 plus 2 is 6, so you get 6 root 5. Root 7 plus root 7 is 2 root 7. Those two cannot be combined together any further because they are not like radicals. Number 2, 12 breaks up into 4 times 3, so it's 2 root 3. 27 breaks up into 9 times 3. So that becomes 3 root 3. 2 root 3 and 3 root 3 are like radicals, so you can add 2 plus 3 to get 5 root 3. Number 3, 48 breaks up into 16 times 3, so that simplifies to 4 root 3. 24 breaks up into 4 times 6, so that simplifies to 2 root 6. They are not like radicals, so they cannot be combined. Number 4, let's find the exact perimeter of the triangle with sides 2 root 6, 2 root 6, and 4 root 3. That means we just have to combine these 2 radicals because they're like radicals. So we get 4 root 6 plus 4 root 3. Enter that number into your calculator and round it to the nearest tenths place. Number 5, they didn't give us the lengths of the sides. We have to find them ourselves. I'm going to label them again like I did on the last page. From A to B, the distance is the square root of 9 squared plus 9 squared. So that's the square root of 162. The distance between B and C can be found just by looking at them. Notice how -3 is the y-coordinate in both of them. So 6 minus -3 is 9. And then the distance between A and C. A has an x-coordinate of -3 and C has a x-coordinate of -3. So that means all I have to do is subtract those 2 y-coordinates. So subtract 6 minus -3 and you'll get 9. So far we have 2 sides of 9 and 9, and then the first side is the square root of 162. That actually breaks down into 9 root 2. Adding those 3 numbers together, we get 18 plus 9 root 2. Enter that into your calculator and round to the tenths place. Let's actually find the perimeters of some figures. In 1 through 6, we're going to find the exact perimeter. Show your work. Number 1, we have a rectangle. The left side and the right side have lengths of 4. The top and bottom have lengths of 6. So you just need to add those numbers together and you will get 20. We don't have to worry about units on this page. Number 2, the left side of this triangle has a length of 5. The bottom of the triangle has a length of 4. So I need to get the length of the hypotenuse of this right triangle. Let's set up our distance formula. So we already know the change in x. We know the horizontal change. So we can set up the square root of 4 squared. And the vertical change is 5. So put 5 squared. The radical then, it has 16 plus 25 in it. 16 plus 25 is 41. That cannot be simplified. So add up the 3 side lengths. You'll only be able to add up 5 plus 4. which is 9. So 9 plus root 41 is the perimeter in number 2. Number 3, I can easily see the bottom of the triangle is 6, but I can't easily see the slanted side. So what I'm going to do is I'm going to drop an altitude inside this triangle and create a right triangle on either side. The right triangle has a bottom of 3 and a height of 4. So that means the hypotenuse would be 5, because this is a 3, 4, 5. The same is true on the other side. It's the same size triangle. So the perimeter of this triangle is 5 plus 5 plus 6, or 16. Number 4, I can see the right side and left side are 4 units each. The top and bottom are slanted, so I'm going to draw in an altitude right here, and I get a triangle up at the top. The one leg on the right is a length of 1, and the other leg of the right triangle has a length of 4. So in order to get this remaining side, maybe I'll put a C there, C is the square root of 1 squared plus 4 squared, which is 1 plus 16, or 17 under the square root. So this side is the square root of 17. We have the same kind of triangle down here. You can draw it inside, or you could draw a triangle outside. Either way, it has legs of 1 and 4. So that means the hypotenuse is the square root of 17. You have to add up those 4 sides then to get the perimeter. You can add the 4's together, so you'll get 8. And root 17 plus root 17 is 2 root 17. Please pause the video, try numbers 5 and 6, then turn the video back on to check your answers. The top of this one is 2, the bottom of it is 7, but the right and left sides are slanted. So I'm going to imagine a right triangle. The one on the left has a leg of 1 on one side and a leg of 4 on the other side, and we did that in the last problem. So I know the hypotenuse will be root 17. On the right side, drop an altitude so you create a right triangle. The height of the right triangle is 4 and the other leg is 4. So then I can set up a distance formula for that. The horizontal change is 4 and the vertical change is 4. So you do the square root of 4 squared plus 4 squared, which gives us 32. And 32 is 16 times 2, so that's 4 root 2. This slanted side is 4 root 2. Add up 4 sides. 2 plus 7 is 9, plus root 17 plus 4 root 2. Number 6. The top has a length of 2 and the bottom has a length of 2. So now I need to find the slanted sides. There's 4 of them and they all look the same. They can all be drawn in as a hypotenuse of a right triangle with a leg of 1 and a leg of 2. So that slanted side is going to be 1 squared plus 2 squared and take a square root. So it's the square root of 5. All 4 of these are the square root of 5. So there's 4 square roots of 5 plus 2 is 4. Please pause the video and do the closure, then turn the video back on to check your answers.